Hello friends, today I'll show you how you can create a convolutional neural network to make a classifier which can classify dogs and cats from an image itself. So let's get started. I'll show you how you can train the model on Google Cloud. You can use your own PC or laptop, but mine doesn't have that much capacity, you can see. So let's get started. Okay, so this is a Google Cloud platform. Go to VM instances. Okay, I will use 24 vCPUs because that's maximum you can use when you are using a free trial. Okay, now memory 21.75 GB. Linux, I'll use Linux 16.04 LTS. Select computer no service account and create. Okay, so it will create the server. It will take some time. So okay, so this is the repository we will be using. Go to this doc.cat classifier. I'll put the link in the description below. Okay, now click on SSH. So it will show you just command line of an Ubuntu 16.04 machine. Still connecting. You can train this model on your own PC also, but just make sure that you have that much amount of RAM, otherwise it will run out of memory. So okay, now let's get started. Sudo apt-get update. First update. Okay, sudo apt-get update. Then sudo apt-get upgrade. Yes, Y, press enter. Sudo apt-get unzip space python pip. Oh, I forgot install. So it will install unzip, which is used to unzip your dataset, and python pip.
Forgot
So
to
pip
type in
is
install.
used for installing different Python packages. Install unzip. So you can directly type in pip install and package name, and it will directly install it. Okay, so clear. Now git clone, and I will put this link in the description box below. Okay, so it will download all the codes required. So you can see docs-cat classifier, which has all the code, and wget space this link will download the data set that is required to train that model, which has different images of dogs and cats. I will put its link also in the description box below. Okay, so now you can see docscat.zip. Unzip that file, unzip space docscat. You can press tab for auto completion. It will unzip the whole folder. You can see all the images. Here. Yes. So now you can see this docs-cat, which is the unzipped folder which has all the images of dogs and cats. Okay, sudo pip install numpy space scipy space opencv-python. So these are the packages that we need: numpy, scipy, and opencv. So opencv is mainly required to read those images, and numpy and scipy are mathematical issues, for mathematical issues. Okay, so it's installed. Now sudo pip install dash I tensorflow. Ha. TensorFlow is equal to 1.0. So why it is required? You can directly write sudo pip install TensorFlow, but if you want to use the what can you say, trained model on your cloud into your personal computer or your local machine, then both has to use same libraries. So, and yes, we are using tflearn, which is a wrapper on TensorFlow. So the new TensorFlow update is still not support tflearn, so we have to use particular versions for both. So we will use TensorFlow 1.0.0 and tflearn 0.3.1. Okay, so sudo pip install dash I tflearn is equal to 0.3.1. So now what can you do is you can train model on cloud, and if you have same versions of both the libraries into your local machine, then you can run that trained model in your PC or local machine as well. So now just check it. TensorFlow, import TensorFlow. Yes, it is importing, and import tflearn. Okay, it is importing it. So yeah, it's working. Now change directory to dogs cat classifier and list. You can see apply.py, data.py. These are all the codes that is required. So import data.py, sorry, python data.py. It will read all the images. You can see reading images of dogs. After that, it will read the images of cats, and it will save the whole array into a class. That's a pickle class, pickle.dump. So, and when we will training the model, we will directly import that class, so we can directly import the data set and we will start training it. This will create approximately 1.5 or 1.7 or maybe more than that GB of data. So, and it will be all on your RAM. So try. So this main data.p is our main data that we will use to train, and test data.p we will use for testing purposes. So python space model.py, it will start training a convolutional neural network. So you can see steps, epoch. This is first epoch, that's first iteration. We will use only 5 iteration. I'll show you how. So this is the loss accuracy. You can see, so you can see accuracy is constantly increasing. If you can see that if your model is not good enough, it won't increase this accuracy. You can see it starts with 0.5 and now it is going 0.6768, and it is constantly increasing. You can see validation accuracy 0.66. Okay, so this is the code. You can see number of epochs 5. If you see that it's a good model, then try increasing that number of epochs. So I have trained the model. This is my CNN. You can see here model.save mycnn.tflearn. It will create 3 files: mycnn.tflearn.data.index and metadata. So these all files are required when you want to use this model in your local machine or in any machine. Okay. So now let's see how this model works. So this is the code apply.py, which will import. You can see model.load mycnn.tflearn, and this is image name cats slash. So let's see where this image is. So in this folder cats, cat.11737.jpg. Okay, so this is the cat. Now we will import this image to our model. So python apply.py. Let's see what it gives. Oh, pre not defined. Okay. Nano. Oh, nano apply.py. Okay, so where it is. Okay. Oh, it's not predict, it's just pre. Okay, control X, save yes. Okay. Now let's see what happens. Python apply.py. Oh, it's a cat. So you can see it is classifying it's a cat. Now let's give one dog's image. So here, image name, you can give any image name that you want to check. Just give it with a path, whole path. Okay, so now let's see, it's in dogs folder. So this is the image. So you can give any image. Okay, which is the folder dogs slash dog dot which is the number. Okay, I can see it. Okay, 1402. Okay, 1042. Oh, it's 1402. Oh, I gave the wrong number. Okay, let's see, 1614.jpg. Okay, you can give any image. You can see here. You will see. Okay, now let's give this image. Control X, save yes. Python apply.py. Okay, it's a dog. It is good. It's classifying very well. So yeah, that's all. You can use this repository for directly without, you can use it without training. Okay, I have in that repository all the three mycnn.tflearn, meta, index, and data files are given. So you can directly start using this apply.py in your machine, local machine, or in laptop. It's fast, it's not that slow, but just make sure that you are using specific version of tflearn and tensorflow libraries, otherwise it won't work. Okay guys, bye. Bye.